Hi, and welcome to the third of 3 videos for section 3. I'm sorry, the third of 5 videos for section 3.7. In the last video, we saw how to graph a little more complicated rational functions. But what if we start getting some really crazy polynomials? It won't be as easy as just doing our synthetic division and okay, now we can move it around. But when we graphed it, what was the first thing we did? We figured out where those asymptotes moved to, and then we knew what a rational function looked like, so we were able to graph the function from there. So then the question becomes, is there a way I can just find the asymptotes right away, plot those on the graph, and then figure out where the graph goes? And the answer is yes, and that's what we're doing in this video. So we're going to be finding the asymptotes of rational functions. So, let's let r of x, our rational function, be of the general form an x to the n plus an minus 1 x to the n minus 1. So we have some degree in the numerator, and it keeps going down until we get a 0, our constant. And in the denominator, we're going to have b of n, b of m, x to the m, plus b m minus 1, x to the m minus 1, etc., down to our constant b0. So we use m in the denominator because n and m might not be the same. So we use m just to clarify they could be the same, but they don't have to be the same. So that's why we choose different variables. If that's the case, first of all, our vertical asymptote, so the vertical asymptote are the lines, are the lines, could be just one like we've had in previous examples, but are the lines x equals a, where a is a 0 or is a root of the denominator. So this hasn't changed. This was the same as when we started these videos for this section. Wherever the denominator is 0, that's our vertical asymptotes. The trickier one comes for our horizontal. And so then we have a few different cases. So if n is less than m, then the horizontal asymptote is just y equals 0. So the x-axis basically. So let's call that 2a. 2b is that if n equals m, so if they are the same, then the horizontal asymptote is the line y equals, and now all I'm doing is looking at the coefficients of the highest degrees. So a to the n over b to the m. And if you remember back to the last problem on video 2, what did we have? I think we had like 3x plus 5 over x plus 2. Well, these are both the same. N is equal to m. They're both the same degree, which is what we're saying. So since they're both the first degree, well, my coefficients are what? 3 and 1. So y equals 3 over 1, which is y equals 3, which if you remember the graph, that's where our horizontal asymptote was, right? So they had the same degree, so I have just the ratio of the coefficients of the highest degree term, 3 over 1, so y equals 3 was my horizontal asymptote for that last example we did on video 2. And then C, if n is greater than m, then r of x, our rational function, has no horizontal asymptote. So it will have, which we will see later, it's called a slant asymptote. So it's going to be a line running at an angle, but no horizontal asymptote, meaning what? Slope is 0, so nothing going horizontally. It might be slanting one way or the other, but it's not horizontal. So let's look at an example. So let's find the vertical and horizontal asymptotes of Rx is equal to 3x squared minus 2x minus 1 all over 2x squared plus 3x minus 2. So, vertical ones. We do what? We want to know where's the denominator equal to 0. So I'm just going to set that equal to 0. And now factor this if you can, or if it's possible, I guess is maybe the better word. So we have what? 2x and x. I need to get to 3, so I'm going to have 2 and 1. And that's positive, so plus and minus. Use zero property rule. So I have 2x minus 1 is 0. 2x is positive 1. So x equals 1/2 is one of my vertical asymptotes. I also have x plus 2 is 0, which means x equals -2 is my other vertical asymptote. So I actually have 2 vertical asymptotes in this case. How about the horizontal? So these were the verticals. We set the denominator equal to 0, the horizontal. Well, for horizontal, what do? We look at the degrees of the polynomial. Highest degree here is 2. Highest degree in the denominator, also 2, which means that they're equal. So that's 2b, which means my horizontal asymptote is at y equals the ratio of the coefficients, 3/2, and there you're done. Just the leading coefficients for each polynomial. So your verticals and your horizontal asymptotes. So that's it. That's your sort of quick introduction to asymptotes. How can we find vertical? How do we find horizontal? An example where we do it. So come on back in video 4. We're going to start looking at, now that we have these ideas, how can we sketch more complicated polynomials.